Hello, welcome to the third lesson in electric circuits and circuit analysis. Today we're going to be doing current divider circuits, voltage divider circuits, the delta to Y and the pi to T transformations. Let's begin with the voltage divider circuit. So, as always, let's draw out our circuit diagram. Okay, so what you can see I've drawn here is a series combination of resistors, of n different resistors. You'll see that the circuit breaks here, such that we do not know the total number of resistors in this series combination. And effectively what we want to know, what is the voltage drop over this resistor, Ri, given that the rest are in series. So let's do some basic circuit analysis. What is R equivalent? What is the equivalent resistance of these series combinations of resistors? And we learned that in the previous lesson. R equivalent, or these resistors, sum in series. So we have Vs over Is is R1 plus R2 all the way through Rn. Perfect. Now, we want to know what Vi is. Well, let's do basic Ohm's law, as always. Vi equals Is Ri. So we know that this current flowing through this series combination of resistors is always the same. The intuition behind this is, given we have a certain amount of charge flowing through the circuit, or a certain amount of electrons, the electrons cannot simply disappear. So the amount flowing into a node must be the amount flowing out of that same node. Let's continue here. We know that Is is equal to Vs over R equivalent. So we can sub that in. And it really is as simple as that. The voltage divider circuit states that if you have a certain resistance and you know the total voltage and the equivalent resistance within that loop, you can calculate the voltage drop over a specific resistor. Perfect. Now let's begin with the current divider circuit. Wonderful. Now, we note that the voltage over this node is always going to be Vs, except now that these currents flowing through each resistor are going to be different. So, we note that Is flowing into this node is equal to the summation of all the currents flowing out of the node. That's basically KCL. We want to know what is I of n. This is the current flowing through the nth resistor. Again, we can use Ohm's law. So Vs equals Is times R equivalent. So this is the parallel combination of all of the resistors, as we did in the previous lesson, simplifying resistors in parallel. Let's note, as I said earlier, Vs is the same over all of these different resistors. So let's say, what is In? So Vs is In times Rn. Perfect. We have a common variable here. Let's substitute that in. So In is Rn, Is, R equivalent. We can get In is Is, R equivalent over Rn. Perfect. So here you can see that these two equations are quite analogous to one another. you have a source current or a source voltage, and then you have a fraction of the R equivalent and the resistor that we would like to find, either the voltage over or the current through. So this is current divider and voltage divider circuits.